Shalom. Thank you very much, Himmat, for the presentation and invitation to present our technology today. My name is Shani. I'm a PhD student at the Faculty of Aerospace Engineering at the Technion. My PhD research aims at promoting hydrogen fuel by producing it on demand from aluminum powder and water, and it further investigates the application of hydrogen in fuel cells for electric energy storage. My PhD advisor, Professor Gani, who attends this session, and Dr. Valerie Rosenband, and here you can see our nice lab at the Technion. So the main idea of this technology is producing the hydrogen only when we need it, using aluminum powder and water. This is a very compact and safe way to generate hydrogen. Aluminum powder, aluminum is the most abundant metal. It's cheap, it's very easy to work with. And water is simple. We can use any type of water, tap water, seawater, wastewater, and even urine. When we produce hydrogen from aluminum and water, we also get aluminum hydroxide as a residue. Aluminum hydroxide has a number of industrial applications. For example, it is the #1 fire retardant in the world, so we can sell that, and we can also recycle it back to aluminum. The main application of the hydrogen that we generate is in fuel cells to produce energy. And now let's talk some numbers. What we can do with 1 kilogram of aluminum powder, we can take it together with 1 liter of water and generate about 2 kilowatt-hour. So this is a very compact way to store energy. So the aluminum and water reaction is known. What is new in this research? The main novelty here is how we make this reaction happen. And this is the simplicity. A patented aluminum activation process enables the reaction of aluminum powder with water at room temperature, atmospheric pressure, using only 2% of activator. You can see our aluminum powder. I'm sorry that not everyone can see it, but later I will show a movie, so it will be easier for everyone to see. We buy the aluminum powder, we activate it in our lab in a very simple activation process. And whenever we need electric energy and we want hydrogen, all we have to do is just add a little bit of water. And that's it. So the chemical reaction will soon start. Of course, you can't see the hydrogen, but this reaction releases lots of heat, so in a few minutes, all of you will be able to see the vapors. And it was important for us to show that the technology works, that you can take a vehicle or in another application, fuel it with just aluminum powder, add some water, and generate electricity. So I can show you a short movie of our demonstrators, a car and a boat with a remote control. We bought 30-watt fuel cells from Horizon, combine it with our aluminum powder, and you can see that it works. In these vehicles, we use just 5 grams of powder, and it allows us to play with it for about an hour. This is it, bigger size. So again, the idea is to do this reaction in a closed vessel, take this hydrogen, channel it to a fuel cell. So the only hydrogen, the gas that we have, is just between the reactor and the fuel cell. Okay. So there are a number of applications for this technology, both standalone, stationary, and mobile application. Whenever we need to store hydrogen and to produce electric energy in a very compact way. So just to give a sense of what we can do with our technology, we try to calculate in a few applications what will happen if we take the batteries currently used out and put activated aluminum powder, water, and the fuel cells in. And this is just to give a sense. In unmanned aerial vehicles, we can double the durations. And in underwater vehicles, where we can use the water from the sea and they are not part of the systems, we can take those vehicles and extend their duration by 10. So this is a major advantage. To summarize, just a few acknowledgements to the Ministry of Energy for our grant research, for the Ministry of Science for my PhD scholarship, and we also want to thank the H2FC European Infrastructure Project that allows us the collaboration with the Safety Hydrogen Group at KIT, and also with the Institute for Energy Technologies in Norway. Thank you very much.